Just a quick question. Did you guys try out tuning the llama model on your data set, or was the performance issues for the out-of-the-box model?
Yeah, it was out of the box model. So I'm looking on to fine tuning the llama model right now. So, but yet I have not done it because I thought RAG model, like, in the context, if we provide good context, then thought that it might work for our case.
Got it. Got it. Got it. Okay, interesting. And is this like, got it. Have you guys set up an evaluation framework yet, or?
Not right now. We are in the initial phase. But I'm thinking of going through some of the evaluations, like the ragas, I guess. Yeah, but there are other evaluation techniques as well, like where they have used, let's say, OpenAI's GPT 3.5 or even 4 to generate the baseline answers, which we consider as the ground truth, and then compare to it. So yeah, these are the couple of things we are seeking to look and try for it.
Got it. Got it. Yeah. Okay, cool. Yeah, I had recently tried out I guess the Ragus as well as some like self-implemented chains
Mhm.
for evaluating. And yeah, I mean, the results are, I think there's several variables, right? One, that those pipelines only work as well as your initial data set creation, right? Because you need to kind of create a quote unquote gold truth response to these things. Are all of you guys familiar with these kind of evaluation chains?
So
Or
how have you created the ground truth?
yeah, I mean, what we did was we ended up going through and chunking our entire all of our data and then randomly picking either one chunk or a group of like three nearby chunks. And using those as the input, asking the LLM to generate a question that can be answered solely by the content in those chunks. Um, and then so that was like our reference. Um, yeah. So and then from there, what we did was when we actually went back and had it do the whole retrieval over the entire document, we were able to see like if it was able to identify the chunks that we created it from as the retrieval evaluation. And then for the response generation, it was kind of compared against that ground truth label. Um,
And how was the results like?
Um, it was fine. I think one thing though is it really depends on the types of questions you're answering. I think for us we were trying to do a lot more like summarize what's going on or what are the latest changes that have been made in this data set recently or who's responsible for this. I think it really depends on the types of questions because I think we're trying to do two different strategies, one for like factual retrieval and another one for like these more summarized type of tasks. Because things that are more summary oriented, this data set creation approach doesn't really work because you're trying to create questions that are tied to a chunk or at most like two or three chunks. But for summaries, you're really trying to get a yeah. So I think there's some merit to like being able to first classify your questions and then have different parameters and setups set up for each of them so that like if you'd imagine we were able to see more success with for summarized type questions with the much higher top k in retrieval and then kind of doing more the map reduce type style on it, whereas um for something that's factual, right, you want a really low top k because adding anything more adds more noise and it's more likely to add like extraneous information. Um, so yeah, we ended up creating two different data sets, one for like summarization tasks and one for like factual retrieval. And both of them have different, they're like almost different problems, I think. So
And like
yeah.
for this one, did you use the pre-trained model or fine-tune on your own, or how did you go with the model?
Yeah, so far have just been using OpenAI models, but I mean, I think that's something we probably will do. Yeah. Um, I think we had a project in this group to work on fine-tuning different models on code bases. It became a lot to manage, but if enough people are interested, we can. I mean, I think within this context setting, it's like pretty important. So we might be able to like, sorry,
Yeah, I was kind of
really
quite
get if there's
interested
enough
on it.
interest. Sorry.
Yeah, I was kind of interested on it, but then yeah, I think once there was a group and then you tried working on it, but then something, I don't know, yeah, like you said,
Yeah,
it was more money.
it's a lot of oversight. We can discuss it after at the end of the meeting
Yeah,
if
so
people are interested. Okay, let's. I think someone else raised their hand saying they've worked on this. Maybe we can cover it quickly and then we can do the presentation. Ashutosh, was it you or someone else? If you want to share problem with your mic, okay, no worries. We can come back to you. Okay, cool. So that being said, let's probably get started with the presentation. And is someone called Dow Speaker in the channel in this meeting right now? Dow Seeker, sorry.
Yeah, uh,
Oh, is
I'm
that
there.
you? Okay, nice.
Yeah,
Yeah, I don't know who the name to Discord handle, but cool. Yeah, I'll try to keep it somewhat shorter then. If you want some time at the end to cover the papers you had mentioned, I think it'd be cool to do that.
cool. Yeah, I won't need a lot of time. They are like pretty straightforward. So I
Yeah.
guess
Okay.
10 minutes should suffice.
Cool, cool. Yeah, I think this paper too is so yeah, I'll try to keep it a bit shorter.
Okay.
Awesome. Oops, I don't want. Yes, I guess the focus of the meeting, like the okay, I guess it's in presentation mode. Yeah, so the focus for, I guess, all the papers we're going to cover today is kind of this process of query rewriting. If you have noticed, I think ChatGPT, especially the visual model, does this a lot in the sense that you can ask it to like draw me a picture of a teddy bear. And then if you click into, I've seen someone do this, I don't know exactly how, but you can like click into it somehow to be able to see the actual prompt that they're sending the language model, and it's like way more elaborate than your like this draw me a teddy bear. It'll include like details about, I know, teddy bear that is in space doing XYZ. So essentially the main premise here is that like the user's input may or may not include all the information it needs in order to generate like the most optimal response from the LLM, right? Either the user's being too vague, or there's just like additional information that like a human would kind of naturally associate it with that query, but like an LLM wouldn't. Um, or like it's just not optimized for the LLM's performance. Like, you know how even for like vision models, if you tweak it a little bit or like you do the kind of soft prompt optimization, you can get really large performance improvements by random trivial things. Um, so that's kind of this whole kind of line of work. Um, and I think it's like super important because not only for optimization for the LLM, but also if you're trying to just make it do various things, right? So in your especially for RAG applications, right? If you're trying to ask it something like, what are all the contributions that this person made in the last 3 days or like in the last week, right? If you're just doing naive RAG, right, that kind of sense of time is like not going to be there. Or you can ask it to first retrieve things and then provide feedback on what you've retrieved. That's also, it's probably not going to do a great job because Yeah, so anything where it like takes multiple steps, or you need to first filter based off of certain attributes and so forth, all of those things also don't perform well, because it's not something that RAG is built for as is. Um, so yeah, that being said, there's I think a few handful of papers that are covering this. This one specifically is working on query rewriting through like an RL perspective. So they actually train a small LLM um, that is called a rewriter, which will take your input and then rewrite it. And then they train this rewriter to optimize the final response that you get back.
Hey, am I audible now?
Yes.
Yeah, I have a question. So,
Yeah.
while skimming through the paper, I saw that, if there are multiple questions in the same query, it is able to split that. I also work with a RAG system, and I see that a lot of queries are a part of the conversation. So user doesn't write the queries beforehand, and they are trying to interact with the LLM. So does it also cover a use case like this?
Doesn't write the wait. What do you mean by that?
So I'll give you an example. So for example, let's say user writes VPN, and the VPN itself is not a good enough query to retrieve anything, and then uh, it's a multi-turn conversation, and it gives the user gives another information that it is trying to download the VPN or something, and this whole query can be rewritten. Does this also cover that?
I see. So you're
Rewriting
you're
the
asking
query?
you're asking more specifically with regards to rewriting it with all the conversation history in mind. Is that right?
Yes, yes, yes.
Got it. Yeah, I mean this paper isn't focused on conversation more. It's more focused on rewriting it to optimize it for search. So as you can see, there's like this
Right.
web search module. Um,
Okay.
sorry. But I feel like the premise probably would apply to conversation history too. I don't know. We can discuss how it would, but yeah, their specific focus right now is trying to get it to
Yeah,
optimize for
going through the
retrieve.
approach, it looked like, yeah, it will go through I mean, it will work for conversation as well, but I did not find any specific example of it. Okay.
Yeah, I mean, I think it would. I don't think there's any reason why it wouldn't, but yeah, I don't think that's something they focused on in this paper specifically. Um, yeah.
What is the retriever
Um,
they are using?
so they actually have I think it's just some sort of a search engine. I don't remember which one it was. Maybe DuckDuckGo, one of them. Yeah, it's actually a web search, so it's not like a document retrieval. Um, Yeah. So okay, I'll just explain this diagram a little bit. So what they're saying is this one on the left is what everyone's kind of used to, right? It's the retrieve then read. So there's a retriever, it retrieves stuff, and then the existing black box LLM just uses that to generate response. So I don't know if how many of you guys were here for the meeting not last week, the week before that, when we covered I think it was self-refine or self-rag, one of the two. Um, it was discussing kind of training an LLM to figure out when to make calls to include information, and then it kind of updates the whole log likelihood process to generate different outputs based off of the retrieved content that it thinks is the most useful, and then in its beam search it chooses the best generated response based off of the input documents that it thinks is the most relevant, and then uses that as the final response. Um, yeah, so this is kind of similar to that in the sense that they're kind of addressing the problem that with the RAG in its conventional form right now, the LLM is pretty decoupled from this retriever, right? There's some orchestrator, right? In most cases right now, it's this agent or LangChain or something that people are using that goes out and figures, okay, I'm going to go retrieve these documents and then just stick it into the LLM and then it does stuff. But this paper, as well as the one we read before, it's actually trying to get the LLM to okay, so in this situation, there are two separate language models. There's a small LLM, as you can see here in the trainable rewrite, retrieve, read. So they're training this little pink box that will rewrite the query such that it's optimized for this rest of the pipeline. So based off of the output, it gives a reward, and then that updates the small LLM using kind of a basic RL system in order to optimize the entire retrieval flow. So that based off of the user's input, it's generating the best query to search the web, so that now you have ideally better documents, and then based off of the reward and how well that response did, it will kind of update this. So it's not just based off of the user's input, it's based off of, yeah. So as you can see here, right, the input was profession, do they have in common? It kind of rewrote the query into these two things. Then it gets all the documents, and yeah, kind of optimizes the entire flow. So yeah, this is kind of different than that other paper, because the other one was like one LLM is training the actual LLM itself in order to determine when to retrieve and then how good the retrieved sources were. And after generating like 5 or 6 beams based off of the retrieved sources, it picks the best one. So yeah, I think these are two different approaches. I think there's obviously many more, but they're all addressing this kind of question of why should retrieval and the LLM kind of be isolated? It's not like the best way to optimize the end-to-end workflow. Cool. So yeah, this kind of just summarizes that, I think. So the current paradigm is retrieve then read pipeline, as we showed here, right? Retrieve documents externally, pass them to the LLM, generate output. And their proposed paradigm is this rewrite, retrieve, read. So they first rewrite the query, then they retrieve it, then they read it. And unlike previous approaches focusing on adapting either the retriever or the reader, this approach pays attention to the adaptation of the search query. And they say there's a gap in the input text and the needed knowledge for retrieval. They first prompt LLM to generate a query, then use the search engine to retrieve the context. And yeah, this kind of rewriter is a small language model that's adopted as a trainable rewriter to cater to the black box LLM reader. Yeah, and I said, for this case, they're specifically doing it to rewrite web search queries, but yeah, I think there's I've definitely seen other startups at the very least do something similar where they kind of train a little thing or use few shot prompting, etc., to get it to rewrite like filter queries, get it to rewrite to include more kind of related terms to search and so forth. So definitely an area people are exploring. Yeah, so existing approaches overlook the adaptation of the query. This is kind of the same thing, I think. In front of the retriever step of rewriting the input is added in order to fill the gap between the given input and what the LLM actually needs to retrieve to respond to the question. And this is their kind of scheme, right? They have the small LLM, trainable LLM to perform the rewriting step. And this is called the rewriter. And it's trained using RL, using the LLM performance as a reward, learning to adapt the retrieval query to improve the reader on downstream tasks. Query rewriting significantly improves the Retrieval-Augmented LLM performance. They do a lot of evaluation. We can cover that. And then they show also that the smaller LLM can be competent for query rewriting. So they're not actually, training a large GPT-ish thing or fine-tuning any of those large models. So they're trying to say that's like efficient and effective to improve the performance. Cool. Yeah, I think the whole training using RL makes it a little harder to just adopt. But yeah, I mean, in my experiments as well, I think coming up with ways to rewrite it's definitely helpful. And then if you can actually tune it based off of like how well the responses are doing. I feel like this is something similar to what ChatGPT is doing for its visual models, in order to kind of give you good responses. This is kind of their formulation of the rewrite, retrieve, read. As I said, given a data set of knowledge-intensive tasks, just a data set X, Y, where X is the input, Y is the desired output. They first query rewrite, which generates a query X hat or X tilde for required knowledge based on the original query. Then they retrieve, search for related context, and predict the output Y hat. And this is kind of how they do. So they split up the rewriter training into two phases. The first phase is kind of a warm-up phase, and then the second one is RL. Because yeah, I think this is a common paradigm. Because RL, like in the way they're doing it, we'll cover that in a second. It's like very unconstrained, right? So as you see, they're using PPO, and they have this kind of super, yeah, pretty much the state space is a finite vocabulary and sequence length. The action space is anything in the vocabulary. And then the transition probability is determined by the policy network, which is this rewriter model. The reward function gives a reward value dependent on the current state, and gamma is like a discount factor. So they're really kind of trying to allow for any possible next step. And given that this is, I think we've read papers a long time ago on kind of using RL for language generation instead of using log likelihood. And I think one of the biggest things there is just because of this unconstrained sample space, that those original models were essentially, they chose the initial policy to be either a pre-trained LLM that was trained on log likelihood, so it already has a good policy for what these transition probabilities are. Because if you try to train something like this from scratch, it like will take forever, and I think the rewards are too sparse for it to like ever become good. So sorry, because of that, they kind of have this warm-up phase first. And that kind of sets it at a good enough place such that the RL part is really just for kind of tuning. Yeah, so they prompt the LLM to rewrite the original questions X in the training set and collect the generated queries X. Yeah, I couldn't format this, but yeah, X hat as pseudo labels. And then the collected samples are filtered. Those that get correct predictions from the LLM reader are selected into the warm-up dataset. Yeah, sorry.
So, like, which LLM are they fine-tuning using this objective? Is this like the query rewrite smaller LLM or like the bigger
Yeah.
one?
They're not tuning. So they still treat the main LLM as a black box, right? But this one is still, it's untouched. The only thing they're really doing is they're training the small the small
Okay.
one that they use. I think they said they used Vicuna, like 13 billion parameter, or I think that's what I remember. Yeah, a 7 or 13 billion parameter model for this one. Sorry. And
What is the reward that they are using?
the reward is yeah, I think maybe I'll double check exactly what it is, but they have I think it's this. The reward function R reflects, I don't have the exact function, but this is what they said in the paper was it reflects the quality of the generated queries, which needs to be consistent with the final evaluation of the task. I know that's pretty vague. I can double check what exactly they have in the paper.
Cool.
Yeah, it is. Yeah, either a heuristic. I don't know. Let me check. Actually, I don't know. It just says the reward function R gives a reward value that depends on the current state, obviously. After finishing the retrieval and reading, a reward is computed by evaluating the final output. A score of the reward R is formulated. I don't remember reading what okay, so it says the reward function reflects the quality of the generated queries, which needs to be consistent with the final evaluation. X hat is fed to the retriever and the reader for final prediction Y hat. A part of the reward function is the measure of Y hat compared to the golden label Y, denoted as reward LM. Besides, a KL divergence regularization is added to prevent the model from deviating too far from the initialization. So I
Yeah,
think,
seems like that instruct GPT objective.
yeah. Is it the same? Does it look familiar to you?
Yeah, it is like the PPO objective.
Got it. Okay. So yeah, does that answer your question?
Yes.
Okay, cool. Yeah, I didn't include that here. Yeah, so as I said, yeah, they're using PPO and the reward function is related to that. X hat is fed to the retriever and the retriever to get the final prediction Y hat. And I think this is an example of what this really entails. So you can see the direct prompt is answer the question in the following format and the answer with 2 stars. Yeah. And then the reader prompt in Retrieval-Augmented pipelines. Yeah, so this one is like direct prompt. There's no actual data. Here they add some retrieved document. And then the prompts for LLM as a frozen rewriter rewrites it such that it says, think step by step to answer this question and provide search engine queries for knowledge that you need. Split the queries with a semicolon and end the queries with 2 stars. Provide a better search query for the web search engine. Essentially, this just shows how it's rewriting. And then these are some of the responses. So they evaluate this on Hotpot QA. So these are generally open domain QA tasks. I think some of them are multi-step. I think Hotpot is. I don't remember. And then, yeah, so as I said, they're training a Vicuna 13 billion parameter as the small model, the small rewriting model. And then these are some of the results on the, MMLU, I think, is a multiple choice QA data set. And direct is like no retrieval. Retrieve and read is obviously retrieve and read. And LLM rewriter is their approach. So yeah, these are the responses: Chat GPT, LLM rewriter, and then this is what they were able to achieve with including Vicuna. And kind of similar for the metrics for the open domain QA. I think the difference between the LLM rewriter and trainable rewriter is the LLM rewriter is probably without the one of them, as I said, right, they have the warm-up stage first, and then they do the RL training. So that's kind of what those two differences are. So this one, I think we skipped over this. So this is how they do the warm-up phase. They said they prompt the LLM to just come up with these generated queries and use those as pseudo labels. And then they kind of filter those. So they say which ones work, which ones don't. So those that get correct predictions from the LLM reader are selected into the warm-up data set. So essentially it's saying, hey, these are good rewrites that kind of generated a good response. And then the rewriter is fine-tuned on this filtered data set. detrain with the standard log likelihood as the training objective. And they do this to kind of warm up the data sets before they do PPO on it. So I think that's the difference between the LLM rewriter and the trainable rewriter ones. Yes, and then these are the results. So yeah, as I said, right, the analysis, the training process is the 2 stages, warm up and reinforcement learning. And the rewriting models have been warmed up on the pseudo label data before RL. So scores at 0 iteration note the ability acquired from the warm up training. And then the RL stage compensates for the insufficiency of the distillation on the pseudo data during warm up training. And this is kind of the performance for both of them, retrieve then read, and then LLM rewriter. And you can see kind of the performance across different iterations. I don't know what iteration means here. Iteration. What is iteration? Is that even a word? Or is that a typo? I don't think iteration is a word. They might probably mean iteration. In that case, I'm not sure if that's like.
Yeah, it must be a typo.
Yeah, I'm not entirely sure what that means. Maybe it's like training epics. I have no idea. Anyway, we can probably maybe I'll look at the paper quickly. It says reinforcement learning validation scores. Okay, so this is the solid red lines show EM red and F1 blue numbers through training iterations. Yeah, it's training iterations. The dashed lines are the expectation maximization scores of the standard retrieve then read method, orange, and retrieval with an LLM as a rewriter, green. Cool. And then, yeah, the retrieved results are first evaluated, then the final responses, QA metrics or indirect measurements. These are, I think, yeah, some examples here of the multi-hop query and responses. Okay, cool. I think I'll keep, that's mostly it for the presentation. Any questions? I mean, honestly, I'm a bit curious to see, yeah, how exactly they were able to get, what exactly they're, yeah, I guess they were able to show improvement by using the RL approach. I'd imagine that requires a lot of training. They don't really have all the details on that. And I'm also curious to see how this would extend to things other than like a web search retrieval. If you want to do more like generate a filtering query or something about the conversation history. There seems to be a lot of different ways to rewrite queries. Not entirely sure how well this extends to all of those different use cases, but okay, cool. Are there other questions about this or other things people want to mention?
Just a general question as well. So for each week we have this meeting, you have a slide very nicely written. So is there a location we can retrieve it in case we need to revisit? I think this slide are very insightful.
So yeah, I think we recently updated everything on our website, so we should have all of the slides / recordings on there.
Wow, that's great. That's great because
yeah, it was definitely out of date for a little bit, but it should be good now.
Yeah, even for the people who are in the meeting, they might need to revisit, and there are some people who missed the meeting. It would be a good reference.
Yeah, for sure. Cool.
So
Okay.
like I had a question. Like in short, basically they are improving the retrieval performance by training the rewriter, right?
Mhm.
So have they like benchmarked any results on like how the just standalone retriever performs versus how the rewriter performs just on retrieving the data, maybe using web search queries?
You're saying like without the final
Yeah,
generation?
yeah, like this is like a rack system. So
Yeah.
just the retrieval component, have they measured on how like what is the improvement in the retrieval?
Yeah, that's a good point. I mean, I think as we were talking at the beginning, having that kind of do you guys know off the top of your head the format of these data sets? Hotpot QA. I'd imagine they have a very specific answer. I don't know the format of the data set, but maybe also these scores, F1, right? F1 is kind of the precision over recall, like it trades those off, right? So I'd imagine that's for just the retriever. I don't know. I don't know the format of this data set to really um, say what they're measuring. You guys know? Is it? It might be the actual answer response at the end.
Yeah, I don't know. Like I'm guessing that Hotpot QA might be having some multiple responses for a given query, and F1 score might be whether like they are actually retrieving that answer or not, maybe.
Yeah, let's just look it up. Hotpot QA is a data set with 100K Wikipedia-based question answer pairs with 4 key features. The questions require finding and reasoning over multiple supporting documents. Questions are diverse. Provide sentence, offer a new type of data set structure. Okay. So it has an answer, a context, a list of supporting facts.
And I think the questions are of the form that was shown in the example, where they are not just direct question. You have to look at 1 or 2 documents to figure out the answer to it. So it might contain multiple sub questions within it.
So, but then in that regard, what does the F1 score on that data set actually look like?
I think because the answers are simple, probably they are just it is just measuring whether they got the right answer or not. I think
Okay.
can you
But if it's actually generating like is it just a binary yes or no? Because these are actually generating. Is this multiple choice? I don't know. I don't think it's multiple choice because I was
can you
looking
open
at.
an example? I think that would make it clear.
Yeah,
There was
sure,
one example that you had showed in your slide.
But this is just the, I guess, okay, maybe there's a specific answer to this. I don't think I had an example.
Yeah, this one.
Gotcha. This?
Yeah, this one. Yeah.
Oh, I guess the answer is director.
Yeah. So I think I think all of the questions are like this, where the answer is one fixed word.
Got it. Okay. Yeah, I guess F1 makes sense if there's like a direct yes or no, like binary value. Sorry, so back to your question, you were asking if they directly did retrieval performance. I suppose if the answer is just one word, there you don't have that synthesis phase, right? So it seems to be a good measure, right?
Yeah, okay.
Because yeah, if you're able to retrieve the I guess there aren't data sets that just do retrieval. So this is probably as close as it gets.
Yeah, that's true. Like, I mean, like, oftentimes, I guess, like, the issue is in a rack system. Where do you attribute the error to, given that
Yeah, but I think
the
in
response is invalid?
most drag we're actually taking those retrieved documents and like generating a free form response, right? This seems to be a much more um almost smaller scope problem, right? It's just trying to extract like a fact.
Yeah.
Okay, cool. Sorry, we don't have too much time for the papers you wanted to mention. I'll stop presenting. Do you want to quickly cover like how this
Yeah,
approach
sure.
are different? Yeah, go ahead.
Cool. Um, I came across this paper a couple of months back uh, when it was just released in May, and it is improving on the retrieval side of RAG, although like it doesn't really show how it performs on including RAG retrieval systems in uh, generating answers using LLMs. It sort of shows how to improve on the current existing information retrieval systems. So what they do is pretty simple. Given a input query, they use LLMs and like using some prompting techniques, they prompt LLMs to generate an answer for an input query, and they generate this answer and concatenate it with the input query before feeding it to a retrieval system. The retrieval system can be something like BM25, which does a lexical search, or it can be something like base DPR, which is like a neural-based retrieval search. So just to give you an example, okay, maybe I can show you a different paper. Yeah, they have like a good example here. So they basically do a few shot prompting where they ask write a passage that answers the input given query, and they have a query and a relevant passage which is generated, and then they question like when was Pokemon Green released? So it generates something like Pokemon Green was released in Japan on XYZ date. It was like first in the Pokemon series and blah blah blah. So the idea is that if you have uh, like enough keywords which are generated in your query, then you will be able to improve on lexical based retrievers. And the interesting part is that it also ends up in improving the neural based architectures, which means that semantically it is being more nearer to the goal passages it is retrieving. And they show the results on a couple of benchmarks. Like the results are benchmarked against MS Marcode FSET and TREGDEL, which are like pretty standard in information retrieval literature. So they have BM25, and when they use query to doc on top of BM25, they see like very nice improvements. Like for TREGDEL, it's like as big as 15% jump. And they also see similar jumps in DPR, although like the gains are somewhat marginal as compared to the lexical systems. And as you keep on uh, improving on this dense retrievers, like these are the dense retrievers with like these are basically distilled from cross encoders. So the gains are even more, I mean, even less marginal in this particular scenario. But yeah, like the overall idea is that with this paper and this paper, it builds on the previous paper in the sense that it generates keywords rather than generating the whole passages, which um, reduces their complexity a little bit. But using different prompting techniques like chain of thought, they show that it performs better than um, just retrieving passages using feature prompting. And there was one more paper in this um, um, sort of series which generated just the passages, and they retrieved documents which are relevant based on those passages instead of um, appending query to it. So that is like the overall gist of this.
Wait, sorry, just so I understand, you're saying instead of retrieving specific passages, it retrieves the entire document.
Sorry,
Doesn't-
like passages or documents. Yeah.
Doesn't that kind of go backwards? Because in the sense of retrieving passages, you're trying to reduce your context window, right? And so you can pass in only relevant.
Okay, yeah. Like I mixed them up. So I meant passages, not documents. So given a query, they retrieve passages, not documents.
But isn't that standard RAG? What are they doing differently?
They are basically generating additional context using LLMs, so that sort of increases their chances of retrieving the correct document. It
And
is
how are they generating additional content?
they are prompting LLM given an input query. So, like I showed you the example, right? So, what they do is like if you have a input query, like when was Pokemon Green released, in the standard retrieval models, they basically try to retrieve passages or documents given this query. Instead, now you have this query plus this passage which is generated, and now they feed this new query, which they call as the expanded query, to the retrieval system. The retrieval system remains as it is.
Wait, so
So
the
this whole
generated
passage-
the additional context is just based off of the LLM's understanding of it.
Yeah.
Okay, interesting.
So,
Does this
like,
whole
I had
passage
one.
does this whole passage become the query? The LLM output?
Yeah. Yes. Passage plus the query. Yes.
I had one question, like, let's say if it was some kind of closed case where the data are not like available publicly, and then let's say it would be more of a factual questions than let's say if I had to ask a questions regarding myself, where the LLM might not have knowledge regarding me, and then if I ask the question, and how would that context be?
Yeah, that is a good point. These models do hallucinate. So, it is very well possible that if the input query is something which the the LLMs aren't aware of, then they will just spout something
Yeah, I almost
nonsense.
feel like this is kind of defeating the purpose. Like the whole point of retrieving documents is to ground it in quote unquote ground truth. But if you're getting the LLM to generate what it thinks is the answer, like additional information, that could, I don't know. It seems like it could add more noise if the whole one of the reasons you're because like let's say you're trying to generate something about context it doesn't know much about, right? It's like someone's personal documents or something. You
Yeah.
ask it to come up with its own idea or like add additional stuff. Won't
Yeah,
that
but I guess in that sense, like the ideal scenario will be to not retrieve anything.
to not retrieve anything? You would want to retrieve and not generate this kind of expanded query, right?
Yeah, I mean, then we go back to the self-RAG philosophy of when retrieval is needed and when it isn't. So, um, in cases where you actually have some um, factual information present, like in the uh, on the web or maybe in your corpus, then retrieving makes sense, and maybe like the LLMs might be able to generate like relevant context for this retrieval process. And I mean, if you can basically consider it as like a two-step process, two different components of the pipeline. One is like LLM generation, and one is standalone retrieval. And um, in RAG systems, we don't touch the retrieval component at all. And like the point is how to make LLMs more robust to the noises which come from the knowledge grounding uh, or the retrieval. And here they are like actually just trying to improve the retriever, given that it is something which is mm, uh, a known information and uh, something which has less chances of hallucinating. But yeah, like hallucination is like definitely a issue for this type of systems.
Got it. Cool.
Yeah. Does anyone have any other questions?
Yeah, in terms of practical application of these papers, I feel like the one we covered today is probably more effort. These two, I guess maybe they're worth trying out. This, if I understand right, the paper you just shared is just a prompt, right? So that prompt gets evaluated by the same LLM to generate some more context and uses that in the rewriting step.
Yes.
That should be simple enough to try, right?
Yeah. That is true.
I mean,
But
I
I
guess
guess
you have a decent concern at how, but if they were able to say it improves, I don't know. Maybe it works for some things, it doesn't work for other things.
yeah, I mean, even in RAGS, like I checked RAGS as well. But I guess like the issue is it remains the same. It is not able to discern well the root cause for a possible error. Maybe like
Mhm.
whether to attribute it to the retrieval part of error and when to attribute it to LLM generation. I think
Right.
that will make it easier to improve the RAG systems
Yeah. Yeah. I mean,
understanding.
mhm. Yeah, I
No,
think
like I was just
the biggest concern with the Ragus framework is just like creating that ground truth data set. Which I said is like decently hard for summarization type questions. Like it's okay if you're
yeah, I
doing
agree. I mean, have you come across fact score? They have a decent uh, like at least answer for how to evaluate for summarization problems.
Oh yeah, I haven't seen that yet then.
Like they basically create chunks of the generated response and then fact check each one of them against some knowledge base. But again, like the issue with that particular approach is you can't actually scale this approach for some like new
Hmm.
data sets or uh, things which are trending and information which is like coming on continuously. So yeah,
Makes sense.
like factual it is definitely a issue.
Got it. Okay, cool. Yeah, I think we're over time. Yeah, thanks for covering those. It's Varad, or is that right?
Yeah.
Yeah, thanks. Cool. I mean, I think we can keep exploring this rewriting thing. I think I'm trying to find a better solution for what I'm working on anyway. So, I think there's obviously more stuff coming out in this area as well. So if you guys have
Mhm.
other suggestions as follow-up, please put in the group and we can cover that for next week.
Okay, sounds good.
Yeah,
See
or
you
I mean,
guys.
if you have any other paper recommendations, we're like pretty open. I think anything in this general area for now is great. And then we can expand out once we feel like we're good on this.